Okay, so here's this loop, and it starts out flat with the page, right? This is a side view here, and somebody rotates it up like that. So I think we can all agree that the flux is decreasing, yeah? Okay, it starts off with an angle of 0 and ends up with an angle of, well, let's figure that out. What's that angle? If this is 57 degrees, right? Is this angle here the same? Is that 57? I think it is. Yeah, 57 degrees. I'm not going to prove it, but I feel like it is. Okay. So yeah. All right. So because if that angle is 0, this angle would also be 0. So I think we're good. All right. That's not a proof, but it's something, right? Okay. So what we're going to do is we're going to find the change in flux, right? In this case, it's the angle that's changing. So we're going to go EMF is equal to NBA over T. And then what's changing is the angle, right? So it's cos theta 1 minus cos theta 2. Yeah? Like something would happen to us if we said cos parenthesis theta 1 minus theta 2, because they're not the same thing, right? Okay, so the B field's not changing, the area is not changing, it's the angle that's changing, right? Okay. So I think we can do this. Let's see, EMF is equal to, it's one winding. Someday we'll do one with, okay, 5.3 Teslas. I keep increasing the magnetic field. The area is 0.82 times 0.82, right? And then it's cos of 0 degrees minus cos of 57 degrees. Now make sure, are you in, let's see, let's just double check. I am in degrees. Okay, this is good. All right, and then that is how long? Takes 0.0063 seconds, because we can rotate those things so fast in 6.3 milliseconds, right? Whoa! All right, okay. So 1 times 5.3 times 0.82 squared times left parenthesis 1, cos of 0 is 1, minus cos 57, parenthesis, divided by 0.0063. 257.58 volts. All right, now, dear Lord, is it clockwise or anti-clockwise? Well, let's figure it out. I feel like what's happening is we're losing flux out of the page, right? Of the page, right? So what we do, if we lose stuff, we replace it. So we're going to replace flux out of the page, right? The way to make flux go out of the page is to have the current flow anti-clockwise in that loop, okay? All right. Yeah, so don't be fooled. This is another tricky question. I think I put this one on the assessment, but they're all the same. So there you go. All right.